Hello, welcome back to the activity, and this is where we are going to build on the accuracy assessment. So we have validated our model. We've assessed the performance of our model quantitatively using producer accuracy, user accuracy, and then overall accuracy. So the next thing we want to do is to use this model to estimate the land cover size by a cover type. So we want to see how much of this steady area is covered by vegetation or water, and this is what you're going to do here. So in the script here, you have all of these things automated. So we're going to compute area estimate. And one of the things you're going to do is that you're going to need your classified image. So in this case, you are going to use the random forest classified image. And then this script here is taking every pixel that is, for example, water, and then once it's done that, it's going to compute area, and then using the scale, which is 20 meter for the Sentinel-2 data we are using. And then once it's done, you're going to get the area in meter square, but the client wants it in hectares. So we are going to use this bunch of scripts here to convert it, the area in meter square to hectares. And then once you have done that, you're going to print it to the console. So if you print this to the console, see what you are going to get for areas. So areas for every class in hectare, that is the one here. And then when you click it, and then so 0 is for water, I think 1 is for vegetation, 2 is for bare land, and 3 we call it agriculture. Okay, so if you click here, so you go about 3,992 hectare of the land is covered by water. And then for vegetation, which dominates the steady area, you go over 300,000 hectare of land covered by vegetation. And then this one, the next one is what is bare land. So you have over 21,000 hectares of land classified as bare. And then the model is saying that it's got over almost 12,000 hectares, covered by crop fields or agriculture. So we again going to use this data, and then we correct this. So bear in mind that the model itself has got some errors in them, and so the model is not 100% accurate. And I'm going to explain to you in the next slide the sources of error. And then all of this error is embedded in this estimate. So you need to adjust this estimate, these values, you need to adjust it, accounting for the uncertainty within the model itself. Okay, so this is what we're going to do next. Okay, before we get into estimating the areas for each cover type, I just want to explain to you the where the errors in the model are coming from. So you remember this is the true positive. So this is where the model is predicting to be right. So that is the diagonal. Okay, so all the numbers outside the diagonal, so the off diagonal values, they are all errors. Okay, so this is an error, this is an error, and that is an error, this is also an error, this is an error. So all the numbers outside this diagonal is error. So what do I mean by that? So for example, we had the 3 pixels observed by you on the field, and then the model predicted how many 3, so that is okay. But when it comes to vegetation, this is vegetation, you saw 31 pixels on the field, but you can see the model predicted 29. So the model is what underestimating the number of pixels you observed here. Okay, so this is omitting the pixels that are for vegetation, and so you can see that in the vegetation side, the model is confusing some of the results with bare land and then agriculture. About 6 went to bare land and 7 went to agriculture. So that is why it is not 31 and it's missing it. And when you go for vegetation, sorry, for agriculture, for example. So agriculture, this is what you observe. The column is what you observe, 10, right? We observe 10 on the field. That is what you selected on the field. But the model predicted 14 pixels for agriculture. So the model, again, here, the model is over predicting for agriculture. So this uncertainty in the model, if you carry it across to compute areas for the cover type, obviously you can see that the areas you have computed for the cover type, they are not accurate. And what you need to do is that you need to adjust for this error of omission and commission that is associated with the model. So the model is under predicting, sometimes it is over predicting. So this uncertainty, we're going to sort of adjust for this error in the next section. So this is where we're now going to estimate land cover area. And to actually do that, we are going to go through these 4 steps. So the first one is that we are going to compute class weight, and then we are going to create what I call proportional estimates. And then once we have created the proportional estimate, we're going to adjust the total mapped area, and then we're going to compute confidence interval. So that is what we're going to do. So these are the 4 steps we'll be going through. And just to repeat myself again, these steps we are going to work through, they've all been covered in this study by Olofsson and co. Okay. So we're using our error metrics. So you've seen this these entries already. And then you see these values. Okay, we saw these values, which is the mapped area for water, for vegetation, for bare land. They are all from Earth Engine. When we did that, you see we got it from the Earth Engine. So when you total the amount of land covered by water and the other vegetation, our total mapped area is 337,337. So 337,337. That is a very interesting number there. So we're going to use this total here to actually compute the weight. And how do you do that? For the weight for water, you have to take this number, this entry for water, and then you divide it by what? 337, and that will give you the weight here. For vegetation, you are going to take the mapped area for vegetation, which is 300,251, divided by what? This 337, the total, and that will give you the weight. So that is how you do it, and then you get the weight for the other cover types. Okay. So the next thing we are going to do is that we are going to create the proportional estimate. And you can see that we're going to use the table we saw earlier where we got the sample count and weight. So you got the total and then the weight here. And then we are going to use this table A, which we created in the last slide, to actually produce these proportional estimates. So how do we produce this table B, the proportional estimates? Okay, so we are going to go across, so horizontal, okay, and that is the user accuracy. So this is where the error of omission may happen, or error of commission is going to happen in this side. So we're going to fix this. And so, for example, if you take this water, and so water is 3 and the total is 3. Okay, so 3 divided by 3, and then you multiply it by the weight. So 3 divided by the total and then multiplied by the weight, and that gives you the proportional estimate for water you see here. Okay, you can do for vegetation, bare land, agriculture, again water across the relationship between water and vegetation and bare land and agriculture, but they are all 0. So if you compute it, let's say you multiply by 0 is 0. So this is also 0. But when you come to vegetation here, you can see it's 18. So right, so 18 divided by the total, which is 22, times the weight. So that is going to give you this 0.728. And then you move to the next one, 1 divided by the total, which is 22, again times the weight, and that is going to give you the 0.041. And then the next entry is 3. So 3 is what? Divided by the total 22 times the weight, and that is going to give you this 0.121. So you're going to follow this procedure to do for all the rest entries to complete this table. So this is how we arrive at this proportional estimate. Okay. So this is me explaining here, that is how we got these entries. So for this one, that is got 18 divided by 22, when you multiply, that's the entry there. And then this, that has got 1, so that is the entry is 1. So you can see that that is the error. 1 went to Berland, so 1 divided by 22 times the weight, and then we got that. And then the last entry is what? We got 3 divided by 22, and that is what we got. Okay. So once you have got your proportional estimate, and this is the values we got, you can see from here, this the values we got, sorry, this is the values we got here. And then we are going to use them here. So we need to adjust the total map, which is 337, using this proportional estimates we got. So we're going to adjust the estimated area. So if you take water is what? 0.012 times the total mapped area, which is 337. Then you're going to get this for water. And then for vegetation, it is what? The proportion is 0.765 multiplied by the total. We are multiplying by the total map because that one we know that is definitely accurate because the size of the area is not going to change. But how much of that study area is vegetation? So we need that proportion. And that when you multiply by the total, you're going to get this. And you do that for bare land and agriculture. So you can see that we have moved from what the map naively estimated, and then the adjusted error. And that is what you're going to see in the next slide. So here you can see that the map at the first pass, with all the uncertainty in terms of the errors of omission and commission, the map predicted that we go 3,933 hectares of land covered by water. But when we corrected for that, we saw that the size is even more, the area is larger than that. And then for vegetation, it's 300,251. And then when we corrected for that, it's actually lower. So this is where we've actually adjusted for the errors of omission and commission. And so now that is playing an influence on these numbers we see here. So this is the area estimated naively. And then this one is one that we have really adjusted for the errors. Okay. So the next thing we're going to do here is now to compute the final step, which is the confidence interval. Okay. Well, so to compute the confidence interval, the first step we need to go through is to compute standard error. And this is the formula for standard error here. So this is just from a textbook. You just take this formula, and then we're going to use this table here. So you remember this table. This is the sample count, and then the area mapped for every cover type, and then the weight. We're going to use this table, and then based on this table, we're going to apply this formula. So that is where we get to in step 2. So for example, I've done this for vegetation. So we're going to look at the proportion. There's some how would I put it? With the standard error for vegetation in this case. So the proportion in terms of the standard error for vegetation, and you can see here is that this one is the weight here. So the weight squared. So when you go to vegetation, let's take this is vegetation, okay? And then so we're going to go column wise and then row wise at the same time. We are going to go across and along. At the same time, we are going to go vertically, horizontally at the same time. So here you can see the weight is what 0.012 here, and then squared. Okay, and then this one here is what is going to be. So it's going to be 0 over the total. So this entry here is 0 for station, and so this is where you are going vertically. So 0 over the total here, which is 0 over 3 here, and then 1, this is the formula 1 minus then the 0 over 3, because we know that this is 0 over 3. So and then you divide it, or divided by the 3 minus 1, so that is given. So you can see the total to be 3 and you subtract 1 from it. So N1 is the 3 here. When you go to the next entry, is 18, right? So that is it. So that's going to be, again, the weight is what? 0.89 squared. And then this is going to give 18 over the total, which is 22. And then we're just following the formula closely. Then 1 minus the 18 over 22. And then the 22 is the total. You subtract 1 from it. So this is actually total. Okay. And then we go to the next entry. So the next entry, the weight is 0.063, and then you square it, and then you take this entry over the total, which is 20, so 6 over 20. And then again, 1, you subtract the 6 over 20, and then the total, which is 20 minus 1. And the next entry is going to what? 7. So this here, the weight is 0.036 squared, and then 7 over the total 14. And then you subtract 7 over 14 from the 1 all over the total, which is 40 minus 1, you can see here. So once you do this and you use your calculator, you are going to generate a number, which is 0.075. So that is a proportion for vegetation in terms of the standard error. So we're going to apply this proportion we have for vegetation in terms of the error for vegetation. So once you have done for vegetation, you can do for water following the same formula here, then bare land, and then agriculture. Okay, so this is just one example for you to do the rest and complete the table. So you go vertically. So this is the vegetation, and then once you know the cover type of interest, you're going to go this in the total. You plug them in the formula and you compute it. Okay. So once you have your proportion for vegetation, which is 0.075, you are going to multiply it. You are going to apply that proportion. So you take the whole steady area. We know the size is to be what? 337 hectare times the 0.075. So what is the standard error in hectares is what? 25,300 hectares. So that is the standard error. So once you have computed the standard error for, in this case, vegetation, we can now compute the confidence interval. And we are assuming that we are working with 95% level. Okay. So the formula to compute confidence interval is this one given to you. So you need the area, then plus or minus. So this is what got the margin of error, plus or minus 1.96, because it's a 95% confidence level. So the critical value is 1.96, then times the standard error got, which is this value here. So once you have got that, this multiply this. So the 1.96 is multiplied by this, and that is going to give you that. And then you ask yourself, where did we get this value from? You get it from previous slides. You can see. So when you go back, you can see that adjusted area for the vegetation. So the error adjusted area for the vegetation, which is 258,063. That is what you are seeing here. So that is it. So 258, the error adjusted area for vegetation, and then the margin of error around that is 49,500 588 hectare. That is what we computed here, okay, using this proportion here. So that is how you compute your confidence in interval. And then once you have that, so you know that we are not going to say that the estimated area for vegetation is 258,063. No, we're going to say that it is 258,063 plus or minus 49,588 hectare. So that is going to be a range to which we are going to find the true value that represent the actual area covered by vegetation. Okay, so that is the essence for reporting confidence interval than just saying a value which normally decision makers don't ask that. They sort of not happy with that. They always want a margin of error in your estimate. In this case, we have used 95% confidence interval. Okay. So I've used the steps to do for vegetation. So I expect you to follow the same steps to work out for the margin of error or the confidence interval for, let's go back here. So you have to do for water and bare land and agriculture. So you are not going to report these single values, but what is the margin of error around it? What is the confidence interval around these values? And we have done for vegetation, which is this one here. So your task is to do for water, bare land, and agriculture, following these steps here. Okay, when you go back, you have to follow the steps here by class weight, proportion, estimate, total map area, and compute the confidence interval. I always ask, feel free to read this paper for further details, but I have to clarify that a lot of the things in this data, in this paper, be very dense, but that is why you got all of this video and slide to help you work through and estimate that. I hope you find this useful, and this is the end of the session for accuracy assessment and then estimating land cover area. I'll see you in the next video. Have a good one.